This is Math Lesson 2-4, bar graphs and line graphs. A bar graph is a graph that uses vertical or horizontal bars to show comparisons. A line graph is a graph that uses a series of line segments to show changes in data. Usually a line graph shows changes over time. Graphs help you see, visually, data by comparing size or showing change. Graphs visually communicate information. A bar graph uses the length of bars to compare numerical amounts. Line graphs illustrate trends by showing how two quantities relate to one another. There are only three possibilities for change between points on a line or bars in a bar graph or histogram: an increase, a decrease, or no change. We're going to make a bar graph of the following data. Students with jobs. At age 14, 33% of students have jobs. At age 15, 60% of the students have jobs. And at age 16, 74% of the students have jobs. Now, the biggest error that people make when they go to make a bar graph or a line graph is they do not know which axis to put the data on. This first column here, the age column, that should go on my bottom axis. That should go on what we call the x-axis. That's going to be my bottom. The percent, what is left here, the percent here, that's going to go on the side. So if I was going to draw a nice little graph, I might want to start by having some nice little straight line segments. So I'm going to have one down here and one going up here. Okay? Now, with graphs, it is absolutely critical that your scales remain constant. I cannot put a scale on the side and start with 33%, then jump to 60%, and then jump to 74%. I have to be equal in my scale. For instance, I might put a line here and say that this is 20%, and then space it out so this is 40%, space it so this is 60%, space so this is 80%, and space so this is 100%. Notice how the spaces between the numbers are equal and each goes up by the same number. I didn't start with 33% and then jump to 60% because that would be a misleading graph because the data would not be accurate. We said that this was going to be on the side, so we need to label it, so I'm going to put percent right here. I need my age down here. I only need three ages, 14, 15, and 16. So I'm going to put 14 here, 15 here, and 16 here. And I'm going to make bars. Now, obviously, 33% doesn't land on my graph. I have to make a little bit of an educated guess. And that's not unusual. Don't be fooled by that. Don't be scared by that either. It just means that I need to figure out approximately where 33% would be. 30% would be halfway between 20 and 40, so I need to be barely over halfway. So I'll put my pen barely over halfway and I'll draw some. There we go, there's my bar. For age 15, I need to be at 60%. This one's a little easier because it lands right on a number. Oops, I didn't want it quite there. I wanted it a little bit closer to my 15. So I'm going to go all the way up to 60. So much for straight lines. I might use a ruler if I was doing this. So there's my bar for 15. And then for 16, I need to be at 74%. 74% is about halfway, a little over halfway. So if I go a little over halfway, I'm thinking about right here. I'm going to erase my stray marks I made over here that I didn't mean to make. Now the last thing I'm going to do is I'm going to fill in my bars because it always looks better if they're filled in. So I'm going to fill them in. So I'm going to color in my bars. There's that one. And there's that one. And then there's this one right here. And last but not least, we should always title our graph. And this happens to be students with jobs, so we're going to put students with jobs. There we go. So now I have a title to my graph. I've labeled both the axes. Notice I labeled the bottom axis age. I labeled the side axis percent. I made sure I had equal intervals, that means equal space between each number. I didn't start with 0 and then jump all the way to 33 and then make the same amount of space go from 33 to 60. So I equaled it out so that each one of these intervals here was exactly the same space apart, and they were each 20% difference. That's really important when you make a graph. You cannot just label the vertical axis, the axis that's going up and down, by the numbers that you have listed in your table. So that's how to make a bar graph, which you will do a lot in science, by the way. Same with line graphs. You'll make a lot of line graphs in science as well. So we're going to make a line graph of running shoe sales. In February, they sold 54 pairs. In March, 86 pairs. April, 121 pairs. And in May, 115 pairs. So I'm going to simply realize that my smallest number is 54 and my highest number is 121, which means I have to go below 54 and I have to go above 121. So I'm going to look at this and I'm thinking, I think if I counted by 20s, that wouldn't be too terribly bad. So I'm going to have 0 here, 20, then 40, then 60, then 80, then 100, then 120, then 140, because 140 takes me above 121, and 0 takes me below 54. This would be pairs sold, so I'm going to put pairs sold right here. And then I need months down here. Like we said, this always goes on the bottom, and this one always goes on the side. When they give you a vertical table like this, all the data that's on the left-hand side of your table goes on the bottom, and all the data that's on the right-hand side of your table goes on the side. So I need to label my months, so I'm going to start here with February. I'm going to skip a block before I put March, skip a block April, skip a block May. There we go. And I like to write them sideways because they're easier to read. So in February I had 54. So I'm going to change colors just because it's going to be a little easier. 40 is here, 50 is halfway, so 54 would be about there. It's not perfect, but it's fairly accurate. March was 86, so I'll go up here to 80. A little bit past 80 is probably going to be 86, so about there. April was 121, so we'll go all the way up to 100 and go just barely past 120, and that'll give me April. And then May was 115, so 115 is going to be a little lower than 120, so probably about there. Last thing we should do, connect them with a straight line, and if I were you, I would use a ruler. I will do the best I can to use my ruler. And I want green for my color because that's what I used. And I think it's this green, so I'm going to that's so much for my straight line. It was supposed to give me a straight line. There we go. Let's try that again. I want this, and I want it in green. And let's see. There we go. Now I can connect my points a little bit better. And there we go. Last thing we need to do, we need to title our graph. This happens to be running shoe sales. And how is this graph helpful? We can now look at this graph and say, gee, April, it seems like from February to March and March to April, the sales of running shoes increased each month, and then when we got to April, it kind of decreased just a little bit in May. It could be because February starts to get to the end of winter and people are beginning to think about running outside, so they need nice shoes to run outside. So obviously, February, a little colder, maybe not a lot of people buy shoes. March, it's getting a little warmer, more people are buying shoes. April, it's spring, lots of people might be buying shoes. Or it's the beginning of track season for many high schools and middle schools, so lots of kids have to buy shoes. And in May, it tapers off a little bit because they've already bought them during the track season. All right, so now, excuse me, remember that a bar graph, otherwise known as a histogram, is used to show comparisons, and a line graph is used to show change over time. So which data display is better to show changes in the price of milk over 10 years? Why? Okay. Well, if you think about it, it's changing over time, and things that show change over time is always a line graph. So I would say a line graph here would be the best display because it's showing change, that how much milk changed over time. okay? Because a line graph shows change over time. In this case, it's over a period of 10 years. What type of display is the most appropriate for the data shown here? Length of circus tours, circus A, B, C, and D. Circus A was 100 days, Circus B was 130 days, Circus C was 160 days, and Circus D was 90 days. Notice here we're comparing two things, or in this case, four things. We're comparing the circus and how many days that it was on tour. So we're comparing the circus to the number of days it was on tour. We're not talking about a change in something over time. So this would be best by doing a bar graph because we're comparing data. And this is the end of lesson 2-4.